observed it yesterday, the costing part, which we were taking out the sales minus the profit one,
Mm-hmm.
the LOD calculation which we
Yep.
have done. The thing is, while we are doing the calculation part for the profit is also positive and in the negative way. Okay, some are in the positive way, some are in the
Yeah.
negative way.
Yeah. True.
So when we are doing it, sum of sales minus sum of profit, it will give. I don't. I think it will give in the wrong way because minus and minus of uh, profit will give it in a costing in a positive way, in a positive number. So
Mm-hmm.
I think we should do a absolute in that while calculating the costing
Okay.
part.
Okay. Well, let me explore this. I don't think so because so this is your product, okay, and so let me bring that. This is your sales, and this is your profit. Okay, so let's say in two line. Okay, so you sold all the accessories for this many dollar, and you made this much of dollar. So when I have to look at your cost, so I'll bring here the cost and see. The product was costing you 152,000, and let me also look at the discount. We are going to postmortem the whole things. So let me also bring the discount if we are giving any discount. Okay. Also, let me bring returned. We have that return, right? Remember we have the return. Now what I'm going to do, I'm going to calculate what was the return percentage, right? Or what value of sales was return. Okay, so that I can bring it actually. First, I'm not going by the percentage, I'm going to calculate the value of sales which was returned. So what I can do, return sales. So for that, I'm going to say, hey, if return is equal to yes, then what I want sales. So this is the if condition. It just check. If condition syntax is what? In if condition, you just write your if, and then what condition you want to check. I want to check return is equal to yes, and then the syntax part is say then if then, and then the value that you want to show. I want to show sales. So what it will do, it will check if this holds true, then only it will aggregate the sales. Wherever there is condition is not meeting, it will ignore those records, those number of records it will ignore. It will only aggregate those records wherever there is a return say yes. That is what this means. So I'll say apply, and let me bring this here. And let me validate this returns things I'm getting right or not. So what I'll do, I'll bring that return first here. I'll select yes, because we have observed sometime the calculations not giving correct, because this is the coming from the second table, my right table. So I'm going to look at subcategories and cells. Okay, perfect. I think this is giving. So accessories has 47,000 of return sales, and let me see here. Yeah, 47,000 is giving. Perfect. Appliance has 57,000 of returns, and here also I'm getting 57,000. Perfect. If I can calculate the total returns value, so if I have to get totals analysis, okay, come to total, show column grand total. So it will give you the column grand total. So column grand total return is 784,000. And here also we can get total 784,000. So yeah, my calculation is correct. Now here, what I'm going to look at, I'm going to look at like no, I'm just going to postmortem data. So see, this is the sales I did. This is the profit say I'm making, and this is the discount I offered on my sales. This was the cost, and this was the return. So let me open one Excel sheet and do some of the manual validations of this data. Then we'll see what is actually going behind the scene. So basically, yeah, the cost is the one that is fixed. No, because the cost is driven by these cells. So first, we have to understand, um, and this much profit that we are making. So profit is fine. Profit means we are actually making all the positive numbers. This cost has been calculated by these cells, but in these cells we have some of the cells which has been returned. So out of 202, we have to reduce this 47,000.
Yeah.
So 202, one second. So please bear with me. I'm also doing it for the first time. I'm just going to take all this data and I'm copying it. Yeah, sales, accessories. This is your, one second. Let me arrange this in this way. And then you have your profit, and the profit is this number. You have discount. This is your discount number. This is cost. And sales was returned. So, okay. This is actually percentage. So let me convert into percentage. Okay, let me clear this. Okay, so we got this for accessories. This was the sales, this was the profit, and this was the cost, and this was the return sale. We know that the cost is a calculated field. So let me not consider this now. So let me take, this is the original sales. So if I this sales and this sales, if I do final sales, if I have to get how much final sales would be from this minus this return sales. Okay, so I made actual sales I made, that is like 154,000. Well, one thing is I'm not sure whether this discount was given, the discount number, it's it's showing at this label or the or actual final sales. I think it could have gone into these labels, right? So now what I'll look at, I assume this discount 8% has been given on the primary sales, the sales which happened at the very first time. Now on these sales, I know that this much of product was returned. So obviously I would have not given the discount. I would have taken back the discount from the customers, right? When they have done this return. So,
Mm.
so I'll completely ignore this part. I'm going to not consider this. I'm going to take discount here and then see like how much from this. If I have to look at the discount part, then I can say like this. So this much was my discount amount, right? This was the discount. And now if I have to look at total final sales, so final sales minus discount. This is the actual, actual amount that we made. And now we are saying we have got profit of this much percent. So this is our actual profit. So if I have to see that how much profit actually we are making out of this total final sales, we are making quite good profit. That is like 34%. That is the 30% realizations. And if you look at this label, how much we are making on the original sales, irrespective of return and etc., discount etc., it says just 24%. Actually, we are making profit wise, we are making higher side because here a lot of things that we are not considering at the first place. And what was those? We are not considering the return sales, then how much discount we gave on the sales, and yeah, and what was our final sales. And on the final sales, we have to consider this profit because this is the actual profit we made. And this profit, if we see from this final sales figure, so this profit is 35% of this 142,000. So that is what I'm thinking. Now, the reason for losses, if there are some losses, similarly, we can also understand there are losses. And you said cost, somewhere costs are
Yeah.
going negative. So for look at this,
Yeah.
here the profits are negative. That means if you look at the cost, obviously the cost is higher than your sales, and that is the it is negative. That could be possible, right? Because if you look at the discount is 28% and look at the return sales, um, yeah, 22,000 was return, and then yeah, and so let us consider this case. This is a good candidate to analyze. Just give me a moment. So I'll just transpose this here so I can get into this way. Okay, and yeah. Okay, so this is my return for book cases. I can see we have the losses. Okay, and here what I'll do, I'll just drag this and I'll drop this, and I'll just do one thing, Alt F9. If I can hit that, I don't know in this computer how it works, but then I can go to options, formula, automatic. Yeah. So look at this profit ratio, actual profit ratio, which is basis on your actual sales. This is my actual profit ratio. Profit ratio means how much profit you made out of your actual sales. That is why I'm calling it actual profit ratio. So this is my actual sales and this is the nominal sales. Actual sales is the one where after adjusting the return part, adjusting the return and discount, whatever sales I made, I'm considering that is my actual sales. Nominal sales where I'm not considering my returns or my discount, etc. That is my nominal sales. So actual profit is like 35% on the actual sales I made here. But in this case, I am making 4% negative profit. That means I'm being on a loss. But what is the nominal profit? Let me see that. Nominal profit. Nominal profit, I think it is lesser than actual. And nominal is just 3% your loss, but actual is minus 4% your loss. So forget about this. Now let us understand why this is our in loss. The reason for, if you see the cost, let me off this decimal part. This also. Okay, so return was 22,000 from this total sales was returned, and what I'll do, I'll just take a formatting of this format Panther and I'll just apply it here. Okay, perfect. Yeah, so I can see this is just 130,000 nominal sales. On that, we just got return was 22,000. So final sales was just 107,000, and we actually made a discount, which was basically 21%, and that comes around 22,000. So your final sales realization is just 85,000. Now, if you see the cost of this 85,000, so 85,000 minus actual profit, yeah, minus this profit, if you do, so this minus this is your actual cost. But then, yeah, so coming back to your questions, if this is negative, should I take absolute? Then I say absolutely no. That's a big no, because there is a high chance that your profit can be negative also, and the reason because your cost is high. And
No, but it is only in the case of negative for I was asking that if it is only in the case of negative, so that we can take a absolute and
no,
absolute whichever.
why you think you should go for this absolute in case of see, absolute makes sense only when it is negative. If it is positive, then it will take only the positive number.
Right, right.
But why you think you should go with the negative?
So because I was thinking that the logic which we have put in that the sum of sales minus the sum of profit, the
Yeah,
costing which we are getting is I think is slightly
yeah. So
wrong.
yeah, exactly. So basically, sum of sales. For example, here I'm doing sales minus profit. Okay. So basically, this is our formula, right? This is the logic which we trying to get, and we are trying to get what? We are trying to get cost, right?
Cost.
And the cost is equal to sales minus profit. When the profit is negative, then negative positive it will become,
Yeah.
and that will
Right,
giving
right,
you higher cost. Obviously, yeah,
right.
that is, yeah. I mean, if you If you take a obsolete, then you will be getting incorrect cost value. See, don't you think there is a high chances of some of the product which are selling at a lower price? It happens, right? Some of the in the real market it happens, like due to some reasons, maybe the product are getting expired, or they are closing the business, or they are closing that particular office operations, and they don't mind selling even at some discount, even though those discount incur some losses for them. They are okay with, they just trying to, just
Sell the
just
product.
trying to get maximum whatever money that they can get out from their investment, right? That very much possible, and that is the reason they could have given a higher discount. Okay, so there are different reasons for that. Okay, so but then we are, it doesn't mean that we will change this logic. If we'll change this logic, that will give a wrong interpretations of the whole data. And one way that we are understanding the loss of this, because we say, hey, you sold only for 130,000 and your cost itself is 133,000. Obviously, you are selling lesser than your cost price, right? And that is the reason you are getting the losses. And if you would have taken absolute, then this would have given 127,000 of cost, and then at 127,000 and you are making losses, then that itself not justifying. When you are charging higher than your cost price, then also you are making losses. Why? The why question will come, and it will haunt you. Here it is so obvious that we see the cost is high and the sales price is low, and that is the reason we are getting the cost. And this is very, very much possible. That happens many of the time, especially when someone want to clear their stock, all the old stock, and they just want to replace it by the new, and they have a fear like this will go out of the market, and the outdate, and then the product will become outdated, or the product will get expired in very short span of time, and they won't be able to get any money on the investment back. So in that case, I don't mind even if I'm making 10% losses or 5% losses. I'm happy that I'm able to retrieve 90% of my money back. Otherwise, all this money would have gone west on those products. So this kind of things happens. So anyway, so you should never judge that if the numbers are negative. You should take absolute, especially in this case. So think on this rationality of your logic. If your logic is rational enough, then only you should go with this, and probably you should check with your stakeholder, especially the business analyst guy who has worked with you. He will helps you in terms of any logic building. If you think there are some logic customizations, etc. needed, then before taking any assumptions, you should also confirm this with the business partner, because they may have the strong business, they have the strong business acumen, they understand the underlying things very well, and they can help you to understand the data part, and they can help you to understand, they can help you to build the logics. Though you will bring the logic, but then they will give you the business idea whether you should take in this case, for example, you should take absolute or not. They will tell you that, okay, ignore the negativity and just take the whole number as it is. So I mean, this all case to case basis, it's all depend upon how your business is structured and what they are advising you. Basis on that you should go. So that is one thing that we do.
Okay.
All right, so but looking at this, apparently I feel like you should not take in this case, because in this case I'm this is the sales data and I have worked with the sales data and all. So that's what I feel like. You should not take absolute, go as it is.
Okay.
Okay, now continuation of this LODs, few more thing I would like to just take here. Uh, we just discussed the fixed part and exclude part. Include part also I'm going to touch upon. So I'm going to open a new window, and what I'm going to do, I'm going to show you one include options. So see, in a practical scenario, I can tell you 90% of our time, 90% in our work case, fixed is sufficient to solve the problem. Okay, there is everything comes under the fixed preview, but sometime you may need exclude also, or you may need include also, include or exclude LOD functions. So let us see one example I'm going to share with you when you may need include. So let us say I'm going to look at my category sales, and okay, so this is my category sales. Now I got my sales. Now what if I say my one questions, can you tell me average sales done by each single customers? So what is the average sales price by each single customer? So let's say you made some your total sales was, let's say, I'm just giving you tentative examples, let's say 100,000. Okay, so this is 100,000 total sales, and you have total customers, let's say 100. So obviously when you divide this 100, this 100,000, this guy, I'm sorry, if you divide this guy 100,000 by number of your customers, you will get sales done by each individual customer, and that will be your $1,000, right? So each out of all the 100 customers, averagely they spend $100, sorry, $1,000, right? I mean, that is like a way of saying what was the average that you are assuming each customer have purchased $1,000 from you, and that's how you have made 100,000 total amount. And that is one assumption. But then in reality, different customer would have spend different money with you. Maybe some customer would have spent 10,000, some customer would have just spent 500. In reality, that is one thing. But the when we say average, that means we just trying to understand business prospect, whether how we can increase the average price, etc. That is what becomes KPI for the business people. They look at the average ticket size. What is the average ticket size? They, in a business language, they call it as a ticket size. So what I said, every customer is spending the money, $1,000. They, in a business language, they call it as a ticket size, and they say, hey, ticket size of the customer is 1,000. How we can increase the ticket size? So ticket size is nothing but the average money is spent by the customer. So as I know in this view, I have my categories and I have my sales. Now, if I have to get average price by each customers, so how I can bring? I have to bring the customers, all customers in in my view. So if I bring my customers in the view, then what will happen? It will give me sales for each of the single customers, right? And look at the bar chart. This bar chart basically this bar chart give for each of the, this is Stu, and this is Sten, this is William, this is Joe, okay, Christine, and so on and so forth. So all are the customers name, and what all customers have purchased across different time period. I'm looking at the across the time period, so not on a specific time period. So this is my ticket size. This is not sorry, not ticket size. This is the individual purchase by each of the customers. But if I go by this, I'm not able to look at my category sales. So I'll just ignore this. So this is not going to help us. So what is the other way that I can get average price by the customers? Well, to handle that problem, I can go and I can write one LOD calculation. And what I'm going to do, I'm going to include customer name. So when I say include customer's name, so let's say average sales by customers under each category. Okay. because I already have category here. So I've I have already category. So as you remember, yesterday I told you, when you write fix exclude, then what it will do, whatever you are excluding, that will exclude from the current view. So in current view, if you have three dimension, if you write excluding one out of three, you are excluding one, then two will remain, one will exclude whatever you are excluding, right? Similarly, when you write include, sorry, not fixed, so include, when you write include, so let's say I am going to include customer's name. So what it will do, it will in a way like I bring the customer's name in the next to my category. Similarly, it will include customer along with the category. That means it will also it will also take category into considerations. Along with the category, customer name will come and then it will aggregate the average sales. So let's see. So that's, and then what I'll do, sum of sales. Sorry. Okay. Now close this. Sorry. Here, this is okay. Now this is perfect. So what this means, the whole means, this means, hey, include customer's name with the along with the category in a way like we just bring that customer name um, in a way like we just bring the customer name right here. That is means customer name is including with the category. But in LOD, this will take care just like what we did here. It means the same thing. So it has like in category and then add taking customer name with the categories. Mind it. So that is what include means. Include means with existing dimensions, just take this also. Okay, just take this also. And what is this? Customer name. And then you are saying aggregate the sum of sales. So now in this case, I will not get the um, all of the customers, etc. And now what I'll do, I'll not take this sum, I'll take the average. So I'm getting average sales by each individual customers and in the category. In this three category, for one category, my average sales is 1566. My office supplies average sales is 1118 and my furniture average sales is 1335. Okay. If you would have been wondering what if I do average here, then let's see, if you do average here, you will get different price altogether, right? You'll not get by the customer's name. Here I'm getting it by the customer's name. Customers, each individual customers, by the customer average, I'm able to get this number. Okay. Now, so this way, what is the benefit? I got my category total sales and I also got my category average sales. So both way I can show them in the same view by clicking the dual axis. As you know, dual axis, how we can make it. Now when you do dual axis, both turn into automatic. Since it's automatic, so it turn into bubble chart. So what I'll do, I'll keep my cells, select the cells and change it to, as you know, right, we using the marks, we can customize, we can configure the chart style. So from here also we can change the chart type. So from here I select, I'm going to select cells, original cells as a bar. Okay, and this blue bubble, now average cells is my blue bubble. This I'm going to represent by line. What I'll do, this is overlapping, so I'll just uncheck this. Okay, now say both axes, the x-axis, this is for the primary, this is for the primary sum of cells, and this is for the, this axis for the average cells. Though we have two axes. So by default, it just try to adjust the height but there is an option. If you click synchronize axis, that means what? It will synchronize both axis for both these two measures in a parallel way. So let me click this. But then in that case, since these numbers are very small, average sales are very small with comparison to your actual sales. So this will go absolutely down. So let me show you by this. So in case if you like to see, it is gone absolutely down because here, and let me try to see if I remove zero, if anything, because it's starting only with 200,000 and my average total sales itself is not even more than 1,500. So obviously it will go at the bottom. So synchronization in this case is not helpful. Let it be in a this way only without being synchronized. So at least this way, what is the essence of this is like we are able to compare average sales done by each average sales done by customer across each category and each category individual standalone sales. So here sales is high, so-called average sales is also high. Here sales is low, so-called average sales done by each customer is also low. So it's actually validating your data, right? And here also like this is the second highest sales. So yeah, average sales done by customer is also second highest. If this would have gone other way around, then probably we have to dig down like why is it so? Maybe the logic or the calculation is not right. But then both are supporting each other. So this is just like I give you example where probably you need the include option. Suppose when you want to you want to calculate measures by a different way. um, okay, and then in the measures you want to create a dual axis, and the measures, the second measure that you are creating, that also need to take care of some extra dimensions. So that extra dimensions, and probably that is like also hampering you to not bring the extra dimension into rows or a column cells. So how then you can handle? Then there is a LOD option. Using that, you can include that, and then you can write the calculation and bring in the self, bring in the row self or column self wherever you want, and that way you can able to get the right number. Okay, without disturbing your visualizations. So that is the another example of it. Now we will be learning it when we'll be doing some case studies, etc. Okay, and yeah, use cases, or maybe you'll be doing a project itself. But before I go into case study and the project, I want to cover up the basic topic. So we have covered the basic calculations and the LOD expressions. Now I'm going to talk about the table calculation. So this is going to be really fun, really easy things, and this is like going to save your time and effort and all your pro I would say the worriness. It's so easy that with a click you can get this, and this is like provided by Tableau itself on the view, and that is why called table calculations, because it's only available on the table on the view. So let me create a new sheet and show you right here. I'm going to take text value. So why I'm going to take text value, so that you can look at the numbers, how the numbers are actually happening in case of quick cells. Again, I'm going to take a duplicate, or maybe what I can do, I can take this. Once again, it is not happening. Maybe I can just, okay. So what I'll do, I can create a duplicate of it, and then I can bring this here one more time. Okay. Now this is my original sales and I kept the original sales intentionally so that you can see that original sales, how the original sales number, how the original number is, and when I'm applying any quick table calculations, how things differ. So you can pay a close attention, and the quick table calculations or table calculations, whenever you right click on a measure value, here is the options. This is called quick table calculations. And I think already you all most of you people or all of you have exercised and experienced this running total during the Pareto chart, percentage of total during the pie chart. Couple of items you already have experienced it, and how easy is to get these numbers. uh, you know so for example, if I say running total, you see what happened. Well, so let us see, my starting point is accessories and my end point is table. So running total, like I said, what it will do, this is my original sales, and now this is I'm getting running sales. So whatever I'll click, I'll get those numbers in this field. Okay, so original sales is 202,000, and since start this is the starting point, so running sales also will give me the same thing. But as and when I move to come to appliances, this is my second item. So for second item, individual sales is 154,000. Now running sales, what it will become? It will be the previous one and this one. All these two together, if you add this 202,000 and 154,000, you will be getting 356,000. Okay, running total is nothing but you are accumulating it. At any point, you are adding up all the previous numbers. When you come to art, so art is basically summation of art, appliances and accessories. All three, if you sum, you'll get this number 386,000. Similarly, when you come to binder, so binder plus art plus appliances number plus accessories number, all four number if you put together, then you will get this 628. So this we have seen into Pareto chart, and we saw in form of and waterfall chart also. We saw in form of absolute number, and we saw also in form of percentage of total. So this is my running total sum. Okay, running total sum, and this label what I'm getting, this is like total sales in that way. For example, if you add all this individual item and up to table, from accessories up to table, if you add up all the numbers, you'll get this number. Okay, I hope it is clear to all of you, running sum. So when you need to get a running sum, probably um, a running sum is when we want to visualize, let's say, line chart. So let me bring that order date and cells. You got this line chart, and let me go by this month. Okay, this is your monthly chart. Now I bring that second sales, and this guy, what I'll do to this, I'll take the dual axis. Since both are the same item, right? Both are the same things, both are cells only. So when I bring the dual axis, both will coincide each other. So you will not able to see both of them together. So let me do this. Let me take a quick table and make it running total. Then you see how it goes. It's a straight line going smoothly, because at any point of time it's just adding back the previous point. So obviously the next point will be higher than the previous point. There is no doubt about it. So you can see, like, you can see like how the trends are going. How your This is your average sales. This is a cumulative sales. So especially this is not making more sense here, but I have done one tab COVID dashboard. Let me show you there. Running total making the make much sense in that kind of graph rather than this sales graph. So okay, so you see here, this is my daily graph. Daily ups and down it's showing, right? So this is the cases, daily ups and down. So each individual day I'm seeing. So how much cases came into July 7, June 7? 136,000. This is across the globe. First thing, mind it. That's why the number is high. Across the globe, all the 202 countries, how many cases arises? 136,000 on June 7. On August 3, 261,000. So obviously the cases are increasing on a daily basis also. But if I turn this to cumulative, that means running total. Okay. When I turn this to running total, the fluctuation will not be anymore because it is like adding up all the previous point. So when you look at this number, July 12, so it says 12 million numbers, 12 million cases was confirmed. So what does it mean? It means from day 1 up to July 12, this is the total number of cases because it's adding back all the previous cases. When you look at this, so it says, hey, from day 1 when the corona cases start, it start getting notified, and on August 13, this is the total 20 million cases have been confirmed. So that's why the cumulative, when you have running total cumulative, so last one will show all the total numbers, all the total sum of all the total numbers. So this is what. So this is your running total. Running total will give you this kind of cumulative graph. If you bring the daily active cases and if you convert into running total, the same measures will give you this kind of graph. Okay, and if you do a normal sum of trend, normal sum of trend in our case, in our normal sum of the fluctuations, because it's showing daily, right? And it's showing daily, so there is a fluctuations. But when we come to cumulative, same thing. What I did, I bring another measure. I'm showing a cumulative. This is a straight line, and probably and this is what I have done in this view. There are two graphs actually, and both graphs are with the use of this parameter. This is the parameter. With the use of this parameter, I'm swapping this view. So when you click daily, the daily is visible, and the cumulative become invisible, hide it behind the scene. When you click on the cumulative, that appears now, and the daily become invisible, it hide it. So that's what one hiding, one making visible with the click of this options. And that's why you are thinking the chart is changing because of this, but behind the scene actually there are two charts which are swapping with each other basis on what I'm clicking. I will do this, we'll learn this when we'll go to dashboard. Okay, but for now just try to learn all this whatever that we have here. um, Quick table calculation. Okay, so running total I did now. Now let us see the second item is difference. When I see difference, basically you are observing. So from the current value, so this is my current, suppose as appliances is my current value. So difference from the current minus previous. So 144 minus 202, obviously this appliances is smaller number than the accessories number, so you'll be getting 47,000 difference. And the art is like 30,000 minus 154, you will get this number. Okay, and this holds meaningful when you try to look at your let's say your order date. Let me bring the order date and let me get this. Let me get this discrete form of order date. Yeah, so look at your monthly sales. So February sales was 4531, January sales were 40,000. Now February sales was down 9,000 down, right? March sales was 51,000 up because March you did 56,000 of sales. From February you had just 4,000 sales, so your jump is 51. So month on month jump if you want to compare, okay, or it could be month on month, it could be year of year. Basically, that month on month, year or year decided by this. You can change to anything. But the difference, the quick table difference, what it will do, it is not going to look at what level of granularity you have uh, in your dimension. It is just to look at current point, the difference between current point and the previous point. This 2 point cut difference it will give you here. That's it. I have even if I have yearly uh, you know yearly sales, still what I'm getting here, I'm getting 17 minus 16 sales, and that is this 18 sales minus 17 sales, difference is 135,000, and so on. So no matter whatever I do in my dimensions, that is irrelevant. I'll My difference, running total difference, will give me difference between 2 points number. Okay, so basically when you want to see the jump from the previous time period, right, and especially difference make meaningful when you're trying to compare on a timeline, how is my growth, how is my growth from the previous time period to current time period. Maybe it's a monthly growth, or maybe it's a month on month growth, or a year on year growth, or quarter on quarter growth. This kind of terms you would have heard a lot, especially into financial domain, especially when you see that stock market. Even if you experience a stock market investment, etc., there is a lot of terms comes like YOY growth. They say, hey, how was the company YOY growth? That means year over year growth. How is the month over month growth, quarter over quarter growth? So that means from previous year to this year, how much growth has come, or quarter on quarter growth. Then they say what is the growth from the previous quarter to this quarter. Okay, and this is sort of terminology that they use, and this is nothing but the difference between these 2 point, and that is what we can instantly we can get it from this difference. Okay, now this is the absolute number difference, so that is I'm getting an absolute number. So if I say what is the difference between 4531 minus 14,000, so this is the difference is 9,000. Okay, but when I say in terms of percents, can you tell me what is this 9,000, what is this 9,000, negative 9,000 from the previous sales? So it's just very simple. When you want to look at the same things but in terms of percentage, so you select percentage difference. So this is the 68% down from the previous sales. From the January sales, February sales is 68% down. March sales is 1001%, 138% up. Again, April sales 48% down. March sales again 13% down from the April, and so on and so forth. So each month you are comparing, right? And when you look at the yearly sales, you say 17 sales 7.77 up, 18 sales 23% up, 19 sales 14% up from the previous sales. So that's how you are just looking like how the sales progress is happening on a monthly basis or yearly basis or quarterly basis. That time frame you can decide from here. Now let us see some more quick table. Percentage of total. So as we learn in the pie chart, if you have three slices, three categories we had, technology, office supplies, and furniture, and you want to look at how much one each of them contributing into total sales in terms of percentage, then you can convert this. Now when I did percentage total, so now I'm able to see each individual months how much they have contributed in my total overall sales, right from the starting, right from the beginning up to December 2019. Okay, it is showing just each single month in in the overall business. So I can see January overall sales is 0.49%, February is 0.16%, so on. So you can keep. So this is like in this context, this is not that important. Maybe this is important when we want to look at the high level picture. For example, when you want to look at when you want to look at this. And remove this. Yeah. So total sales is what? Let me bring the total here. So all these three together every time whenever you sum up all the individual component, when it's a percentage of total, it has to be 100%, right? And the 100% ka breakup is this one: 32%, 30%, and 37%. Furniture sales is 944,000, which is 32% of this sales. Office supplies is 30%, which is, you know, 30% of this sales, and so on. So that is our percentage of total. And there are, yeah, these all are really, really helpful when, especially when you do, some analysis, etc. That is going to be really super helpful. We don't have to worry about writing this all calculations by your own. And these are the most frequent calculations being used. That's why Tableau has put all of them into quick table calculation, so that the most frequent calculation which we need, all most of the point of time, that we can get it right from here rather than going and writing some calculations. We can just get it from here, and just to make your life easy, Tableau has done it. So now let us see what rank does. So rank is like, okay, so rank is basis on number one is the max, the best cell, the best category would be number one, and the second best would be number two, and the third best would be number three. So in terms of the volume, size of the cells, so here the size of the cells is highest, first highest, because you can look at the number. That's why it has got rank 1. And here 944,000, it's actually second highest, got 2, rank 2, and this was the last, so obviously rank 3. So that is your rank. When you want to rank them up, uh, from top to bottom, then you can do this way. Now look at the percentile. Okay, so what is this percentile? Can anyone tell me what do you understand by percentile if you come across this percentile terms? Okay, so see, percentile, do not get confused with the percentage. Okay, percentile and percentage are absolutely two different things. They are not same. So percentile, most of the time, if you recall, you would have heard during competitive exams, especially when someone writing CAT exam, or any ZRE exam, or any some sort of competitive exam, you would have heard the terms percentile. And this percentile is nothing but, in a way, to say where what is your position in the overall populations. Okay, in the overall population. So let's say, um, come back to here only. So I'm going to make it subcategories. Let's take some more candidate. Okay, now, and what I can do, I can sort this up from descending. Okay, now let us see. So now, can you understand by looking at this data now? I have sort into descending order. So now you can see the highest chairs has the highest sales. Okay, so let's say these are the candidates, 17 candidates we have. Okay, and they are participating into CAT exams. Okay, and that is their scores. The sales is nothing but, consider that is their scores, right? And let me remove that rank.
It is as like the rank, synonym of the rank.
Exactly. So that way, in this is the rank only, but in terms of percentage. So this is in a one way absolutely right. This is the providing you rank only, but in terms of percentage, it tells how many people are lagging behind you? How many people you have supersede them? So chair is 100% because no one is matching with this number. Everybody is behind this number. So the percentile of chair is 100 because chair is the candidate chair is far away than the whole population itself, and he has attained the maximum numbers, and no one is able to match this number, so he got 100%. So that means he has superseded the 100% of the populations whosoever whoso all are participating in this exams. Now phone got 93 percentile, and the reason because uh, phone has superseded 93% of the candidate. His marks are better than 93% of the candidate. Similarly, storage marks are better than 87% of the candidate. Likewise, table has marks better than 81% of the candidate, and so on and so forth. So it just in a way like it gives like how many people are lagging behind you, or how many candidates are lagging behind this candidate where we are looking at the data. Okay, that is in terms of percentage. So in a way, it is a you can say it is rank. Your rank is also can define, but then mostly it is tells like the populations which are behind you, or in a way like you are above, then you are better than this percentage of people. 87, you are better than 87% of people because your marks is better than 87% of audiences, or 87% of participants. So that is what is your percentile. So calculating his percentile is super easy. You just have to check this percentile, and you'll get this. Otherwise this calculation would have gone a little complicated to get this calculation done. See here, this is the formula to get this. I'll copy this, and this is the actual formula which has been using rank percentile. It's not that complicated, but there are couple of formula, nested formula, rank percentile, then sum of this, etc. And again, the rank percentile is a functions. Mind it, this is the function which makes your life easier. It's not a straightforward formula. Using the function, Tableau also has done this. And moreover, one more thing I can just want to highlight. Can you notice this cells and this cells? What is the reason? What is the difference? There is a triangle. Can you notice the triangle? So wherever there you see the triangle, that triangle means it's a table calculation. The normal calculations and the table calculation, the difference is the triangle. So looking at when you have to identify whether you know if you're looking at someone dashboard, you have downloaded some workbook, some internet, and you are exploring it, you may see this kind of things. And when you see that this sort of things, then it is just to helps you identify whether the user has done this calculation by his own, or he is like taking some table calculations. So this is one way of representing. This is a table calculations. Okay, now let us see what all things we have. Moving average. Okay, so let us see the moving average part. And again, I'm going to bring the order date, because when I look at any trend line or etc., moving average basically for the trend line. When I see trend line etc., maybe the order date, I should look with the date rather than the categorical data. So this is my continuous. So I'll make it discrete to get the all numbers properly. Yeah. So see that colors are changing from green to blue. When I turn this to discrete, it's become blue. When I turn this to continuous, it's become green. Okay. Then green, when I have green, then I may not able to see those individual number because it's continuous. And continuous means it's try to um, gives you without any distinction, it gives you all the data point. Well, I will not discuss those things now. So let us see um, the month. Okay, so now here what I'm going to look at, I'm going to look at the moving average. See what it happens. Now, so let me talk about what is the moving average means first. See the moving average. Let me open a Paint. I will get my this thing screenwriter soon, but I'll manage this time with Paint. See, I can tell you moving average is like on a on a on a on a chart, on a line chart, basically. Uh, so let me first show you this line chart. Let me convert this to line chart. Okay, so this is my regular sum of sales trend. This is my line chart for sales, and this is my moving average. So can you notice any major difference? Any major difference? I can see one difference is that this graph looks more smoother, or not more smoother, at least little smoother than the previous graph, than the sales graph. And why that smoothening has come? Here it's more volatile, more ups and downs you can see in the sales graph. But in this graph, the sharpness has been reduced. It is like more little smoothened. The graph has little smoothened, and that is because of the moving average. We are taking the moving average of cells rather than look taking the individual cells, all data points of the cells. We are taking the moving average of cells, and that is why the graph has little bit smoothened. Can you observe that now? Right, look at that. Here you have sharp ups and downs. Here we have smoothened, that sharpness has reduced. Here we have reduced the sharpness, right, at every point. So that is because of moving average. Now let us see what moving average do. So what I'm going to do, let me take this copy of it and let me explain this to you. So this is a concept which if unless I not explain you visually, you will not understand. It's a unique concept. So let's see. I'm taking this area. I'll copy this here. Okay, this is my graph. Now on this graph, um, okay, when I say moving average, so I have like different time period. You see, I have like each of this monthly. This is a monthly data. This is March data, April data, May data, June data, and so on. So at any point of time, let's say for this time period, okay, what it says in the moving average, it says moving average from the previous two to the next zero along month. So previous two, so it is taking previous 2 point. So at this point, let's say September, this is the September. So what it doing, so in this graph, the bottom graph, what it does, it takes the September and the two previous. So what is the two previous? August and July. So September, August and July, three numbers. So September is like 120,000, August is 45,000, and July is 49,000. So all three number it will add up and then divide by 3. Okay, because I'm taking the average. So I'm taking average of the three. Then you know that how do you get average? You sum those quantity and then divide the number of quantity. Then you get the average. So I'm just getting average, and the moving average here I'm getting 3 points. So because if you look at the hover over definition of moving average, is the previous two to the next zero. Previous two, so that means previous two, so leave the current, go previous two. So previous two is August and July, since I am looking at the September. So July, August, September, and divide 3. So whatever number will come, that number it I am seeing here. So my average is coming 71,000, and that we can validate into let us say a here. So let me take 122, 125, 46. That was the number I saw. 125, 46, and the August is 45, 171. 45171. And July, sorry, August is 45171, and July is 49168. 49168. Okay, so if you add all these three, so you'll get 214885. And if you take average of these three, you will get 71628. How do you get average? You just like you just sum them up, and this is my summation. You can see the formula sum. I took a shortcut way to get this. This is my sum. And if you divide sum by number of candidate, how many is 3? You'll get this 71,688. In Excel, here also it's giving the same number, right? So that is what we are average. Now let us see. September is 120,000, and here how much September average we are getting? 71,628. 71,628. Forget about this decimal part. It's ignoring the decimal part, but that is what I'm getting. Understood now? So moving average, basically this is my each individual month, but here I'm basically adding previous 2 months and I'm dividing. So basically I'm taking for every 3 months at any point of time, I'm adding up 3 months. I'm actually taking average of the 3 months. Okay. Similarly, when you come to November, you are taking November data, you are taking October data, you are taking September data, and you are adding them together, dividing by 3, you are getting average is 78,000. Similarly, when you come to December, you are taking December data, you are taking November data, you are taking October data, and then adding up and dividing by 3, you got December, right? And here, that is not. Here you are getting only September data, only October data, only November data, and so on. That's why the fluctuations are more. Here, the fluctuations are less because we are now taking average. When you take average, obviously, you know the average smoothen line. Why people look at the average? Because just want to get a tentative idea like how things are going, right? When they look at each individual candidate, they may not get a good idea. For example, when you say, hey, what is the average placement package of this college, or what is the average package that been offered from IIM Ahmedabad, they do not ask you what is the everybody package. They just ask you average package. Someone when they want to assess a college or brand, right? That gives you an idea. Okay, if I get into this institute, at least this could be my package. You know, I will be getting near about this, more or less about this. This is going to be a ballpark figure. So that ballpark figure is your average. So that average I'm taking in this account just to smoothen my flat so that I can see a better trend than this. At least my moving average gives me a better trend in terms because the data has been smoothened by looking at the average. So this is giving a better trend rather than looking at the individual cells. Okay, now here is the quick tweak. So this is like a very uh, fixed moving average, but we can also customize the moving average as per our own wish. What do I mean by that? In this table calculation moving average, you have only options here in this. Uh, you do not have option to customize. You can just select moving average, and what it will do, it will add up all the three date points and divide by 3. But then if I say I don't want, so that is called 3 days moving average or 3 points moving average. Okay, but I want to calculate 10 points moving average or 20 points moving average or 50 points moving average. You understand what I mean to say when I say 10 points or 20 points or 50 points? Okay, so now go back to previous 50, add up everything and give me the average numbers at any point of time. So that will be further smoothen the curve like anything. And especially that is very relevant in the stock market. Let me give you, since we are talking about moving average, so let me give you some perspective, some angle to think about it. How many of you deal into a stock market or like to or have interest into a stock market financial domain?
I'm not in interested in stock trading, but I'm in finance domain.
Perfect. So, I mean, I'm not asking you to trading, but then, yeah, obviously, if someone market, he must be aware of the moving average because the moving average is very, very prevalent in the especially people who are into market. So, let me show you. Let me show you some graph and let me show you some. Okay, let's say Nifty 50. Okay, I'm going to Nifty 50. I open this Nifty 50 and we'll see. You will see the moving average, etc. and we'll learn better. This is the money control just to we here like you know uh, all market information we can get very easily. Okay. Okay. So actually it's loading. Yeah. See, a moving average is also indicator. It's just like a trend indicator. It's a technical people consider as a technical trend. Let me show you if moving average. They usually show this moving average very well. Let me check where they have shown you. Let me see if I have here.
This here also they are showing the tableau, like the charts which are there in this money control. They're using Tableau or what?
Sorry.
They're using a Tableau or what for this showing this chart and all
Yeah,
for
yeah.
Nifty and for money control.
They use Tableau. They use Tableau a lot. Yeah,
Uh,
that's what
okay.
I have seen. They are using Tableau. That's what I have seen. They have like very uh, in-depth views, etc. I mean, there are a lot of things that we can you can find into this money control website. Let me check. Maybe Nifty graph they have not given. Maybe I'll go to individual. I've seen this a lot, moving average a lot. So let me go to any individual stock. We may see there. So moving average it just you gives you an idea uh, what is the strongest trend, like strongest trend, because you are not looking at the days individual days movement or the price. You are looking at a average of so many days. So that price, if you're looking at the average of so many days, that will become the very strong point, right? So anything breaching going above or beyond those point have a very strong. Okay, so look at the simple moving average that they have given. 5 days moving average is 2097 for the Reliance. 10 days moving average is 2102. 20 days moving average is, you know, 20 days moving average is uh, 2108. 50 days moving average, 100 days moving average, 200 days moving average. 200 moving average, obviously the prices will low because when you say 200 days moving average, that means from today price, go back and go back all the way up to 200 is back, almost like more than 6 month or 7 month data point. You are summing up all the individual single day record and you are dividing it by 200. Okay, and then what price you will get, that would be your 200 moving average, and this price you are calculating for from each day perspective. So come back to our visualization now. So that's what here. So here in this case, in table quick table calculation, we can't do any changes. What how the Tableau does? Tableau just take 2 days mm, back data, 2 days, two date points old data, 2 points old. So it can be month, it can be year. Now you decide from here. So two previous point and current point, 3 point, and divide by this. But when I say, hey, I want different moving average. For example, let me show you here, since we are talking about moving average, so let me cover that formula also, and that is called Windows formula. So Windows formula is going to be really super cool and very helpful. Some many people do not cover this in the syllabus, but I feel like I should give you this because that is a little advanced thing, but knowing advanced things not harm you. At least you'll have idea in this video. So later on, even if you are not, if you're interested, maybe you can watch again and again and you can clarify this. So let me show you this. So let's say I want to understand my trend of the business, how things are going, and I'm going to take the sales. Okay, now I'm going to take this as a monthly. So see, a lot of volatilities I have in the monthly sales. I'll take this copy of this, and this, what I'm going to do, I'm going to write a Windows function. So maybe I will not use that. Maybe I'll go to write a Windows calculated functions. Here I'm going to write moving average sales. And what I'm going to do, there is a function called Windows. So Windows function, what it does, it goes and work on a Windows. So I'll tell you about the Windows function. The first only I have Windows average. So here what I'll do, I'll take sum of cells, and then it asks like start and end, and start. So what I want to start, let's say I want to go go to previous 10 days, and up to previous 10 days, you start from the previous 10 days and come to current point. 0 means at the point, at this point of time. For if I'm at the month July, then July. If I'm month of August, then August. So for each point, it will go back to previous 10 points and it will add up, and then it will give you average. So yeah, what error I'm getting? Invalid windows, the Windows start value must be less than, oh, perfect. Yeah, so since I have to go to previous point, obviously, so it has to be minus, right? So minus 10 points means, that means in the backward directions. Okay, in the reverse directions. Okay, so in a way, like, let me show you. So for example, so for each data point is your point, right? Let me take color. So this is a data point, this is a data point, this is your data point, right? This is your data point, date point, and these are the date point. So all are date point. So wherever you are writing a moving average, then you are saying, hey, start from here and go all the way back 10 days for 10 data point, add them all, and then give me average for this point. For this point, again, you are saying, hey, just go from here, you go 10 points back. So 1, 2, 3, 4, 5, and so on. take all those point, take all those point number and sum them up, divide by 10, and then give me that average number here. So that's why for each data point you are calculating the average from the previous 10 data point. So that is what it is now. And this will actually now gives me 10 days average. Instead of individuals, I'm looking at 10 days average. That I can bring it right here. Now this will be more smooth. See, the graph is more smooth because the volatility has reduced because I'm taking 10 days average. Now see this, the first graph is so volatile, but the second graph is very smooth. I'm getting a strong trend line if I look at the long term perspective. If I look at the long term perspective in my data, because I'm taking 10 days, so I can see the volatility has quite reduced since this is a 10 days ka moving average. Let me change to some different colors. I can change the color also. Okay, now I have taken 10 days, right? Moving average. Uh, but what if I want to make it dynamic? Now user decide what moving average you want. You know what? There is a way that I can do make it dynamic. I can create a parameter and I can say, hey, moving average input, and I'm going to take integers and I'm going to take all. Now user can provide whatever users want. Okay, so now what I'll do, I created a calculate field. Now in this moving average field, I'll go to edit. Now I have taken this negative 10. Instead of negative 10, I'll supply my, hold on, I'll supply my this thing, my parameter, and my parameter, whatever value that I'm going to user going to put into parameter, that will be giving to uh, move back, move I mean in the previous in the reverse directions. That will give the number of points that it has to go in the reverse directions. Okay, are you guys getting this concept or not? Can you give me yes or no?
Yeah, yes.
Okay,
Yes.
okay, great. Okay, thank you. If I'm happy to hear that you're getting, many of the time people do not understand, and I since we are into video mode and I'm not able to interact in a classroom mode. So yeah, so please.
Uh, Actually, it is what is happening now. Your screen is getting stuck at some point of time. So that is,
Okay, okay.
yeah, a bit.
Stuck in the sense, but I'm actually stopping it here. I'm not moving my screen. So how is stuck? How it is stucking? It's like, are you not able to see it in a proper sequence or what?
Yeah. That's we are not able to see the proper sequence because it is a bit slow.
Okay.
Getting delayed a bit.
How about other people? Are others are also experiencing the same things or only with the Rohit?
It's getting delayed by a bit, bit of seconds. You may say 5 seconds, 10 seconds.
Rohit, what I feel personally, maybe because of your internet speed or your computer, that could be also reason.
Okay.
Yeah, because see, this is all going over network. So if others are not finding issue, that could be one reason I feel. So what do? You change your device and then see like if you're having lag into other device or not. So that way you can,
No issues.
yeah.
No issues.
All right,
Yeah.
thanks guys. So now this way I have made it dynamic. Now I will ask user to supply what is the reverse direction number you want. And say this moving average input, what I'll do, I'll show this parameter now. Now can you see now? Now my this thing, now my cells and the moving average is almost same volatilities because my moving average is just 1. Now if I do 10, see what happens. Now it has been flattened. If I take 100, see how it goes. See, it's very smooth in. Now here is a sudden jump, but then it is like a very so this is my daily. This is my the amber color, the orange color graph is my daily graph. Daily basis how my cells are moving. Okay, each individual, no, sorry, not daily basis actually. This is my monthly basis. On a monthly basis, this is my cells jump. Okay, so from this point to this point, this point to this point, these are my cells are jumping. Let me do one thing. Let me take daily and then see the volatility. Then it will be huge. Even I'm getting a if even I'm getting at the this is for each individual day, day to day. This is the day to day sales, the amber color day to day sales, and the blue colors on the day to day it is taking 100 days average. The prior one it was 100 months, now it is 100 days. Now it's all depend upon what date I have chosen here. So I have day or month. Now whatever I have chosen here, my moving average will also go as per that selections. So now it is day, so moving average also for the 100 days. It earlier it was months, so moving average was for the 100 months. Now it's day. Now if I change it to let's say 200 days, say the more number of moving average day I will take, the more smoothened it will become. Okay, so you can see the maximum number of moving average you will take. That means you are taking a very long term perspective, very long term perspective. People likewise, I can give you one uh, a, a close example of this stock market things. In a stock market, people who are there are two types of people. One who are like short-term trader, they come for like 5 days, 10 days, they sell back their position and they get rid of the market. Other one, people who are long-term investors. So people who are long-term investors, they don't look at the 5 days, 10 days moving average. They look at the 100 days or moving 100 days or 200 days moving average. So if the stock market breaches going down 100 days moving average or 200 days moving average, then there is a problem. Then there is a something fundamental problem. That what does it mean? It means that hey, this stock has breached the 200 days average price. That means seriously something has gone very serious. Okay, otherwise how it is possible that 200 days moving price your stock can go down? That is not usually possible. Okay, it has to go up. So if so this is my moving average, long term moving average, 365 days moving average. It is going up. So this is really good. I mean it says there is a strong bullish trend in the business. Business is really going upward directions. But in a way, if I would have seen my this thing, my long term trend suddenly is going down, then there is a serious fundamental problem. There is something very serious things are behind the scene which we have to figure out. Okay, because on an average basis, on a long term average basis, if your direction is going in a downwards, that is a serious problem. Daily volatility is not a concern, but as the strongest long term trend should never be down, and if it is down then it's a serious concern. Likewise, what we consider as a serious concern in the stock market, um, when we see like say 200 moving price is 1572 and the current price is what? Current price is 2000 rupees. So the current price is way above than long term price. Even the 100 days moving price is 1700. When the movement it started going lower than 1756, I would say now the trend has reversed for Reliance. Even the long term trend has reversed. So now it's also a perspective like what you consider as a long term. You consider long term like let's say 1 year, 2 years, 3 years, or you consider 10 years, 20 years. So if you consider 2 years, 3 years, then 100 days moving average is sufficient for you. You should go look at the 100 days and say, hey, if it is 100 days, less than 100 days moving average, then even in the I would say like in a 3 years, 4 years trend reversal, and look at the moving average, it says neutral. uh, it's a neutral, neither positive nor negative, and that too on a daily basis. But when you come to monthly, it should be bullish. See, technique moving average bullish. And why is it bullish? Because when you look at the monthly is like 1000 or between the 1400 to 1000, and the current price is way more than those price, like it's 2000. So the current monthly moving average is saying bullish. Bullish means I am positive about the stock going good. And when I look at the weekly, on a weekly time frame, still bullish. But on the daily it is neutral, because on the daily, the like in the 5 days, if you look at the 5 days, that is, or a 10 days, it is just like 2000. And here also I have 2000, so it's almost like very close. The 5 days, the current price is very close to the 5 days moving average. It's a very close, that's why it's saying neutral. So you understand that moving average basically helps you to understand the trend. If the trend is secular, if the trend is a real good trend, a strong trend, or if the trend is reversing, the long term trend is reversing in the picture. And that you can only sense when you look at the moving average. Moving average will tells you if the long term moving average is going down, that means there is something very fundamental serious problem. Okay, and you should exit that position. Similarly, if your business, then obviously, um, before it turning into moving average, executive would have taken calls, and they would have done a lot of things would have come out of the business as a news, something going really wrong. So yeah, so that is your moving average. It helps you to understand the trend. And how you can do that, if you want to make a customized moving average trend, we did we use the Windows functions. And what is the Windows functions? Windows average. Okay, Windows functions, actually this is also called moving functions. Windows functions or moving function is same. The other word of Windows is a moving function. Why the word Windows come? Because on the screen, on this window, on this view, whatever is visible, it is going to calculate on the basis of that, because it has to move, right? From this point, you say go 10 days in the reverse direction, that to go and take all the 10 days and whether it will sum or average basis on what function you have chosen. I have chosen average, so it will average it. Okay, so that is called Windows function. If I have taken 365, so from this point, or any point you point out, from any point, it will go 365 days back. Okay, all the way 365 days back, wherever it you know stop at 365 in the backward direction, and take all data points, sum them up, divide by 365, you will get your average. Okay, any point you see, the moving average is the summations of previous those many data point. Okay, I hope this this would be clear. So look at the 28th September, and look at the 20th September moving price is just 2693, 2968. Okay, but if you look at the individuals, 100,000. So that's how the moving average comes, because here this is like 100,000. What about others? Others are really small, right? If you look at the others, 1912, 20, those are really small numbers. So that actually take into consider, smoothen your data, and it gives the average, and average is strong indicator for you. The longest moving average you will take, the longest pictures you are looking at the longest term pictures, and the longest trend you are going to assess. The shorten moving average you will take, the shortened time frame you are going to look at. That means you are not going to look at the very long term, you are going to look at the short term trend, how in the short term things are happening. Okay, so for example, if I look at only 10 days moving average, this is my short term moving average. Now see that it is has more volatility, and maybe if I can go to monthly, I can change it to monthly, then this 10 days at least better. So now this is my monthly sales, individual sales, and this is my on a monthly basis 10 days moving average. Okay, so that's what it is. I hope this would have given some ideas about this whole things.
So, it is. I have one
Yeah,
question here.
please.
So, for, when you're taking for monthly basis and you are giving a parameter as 10, so you are taking 10 months,
Yes,
10 months average sum.
exactly. That's right. Exactly. You are right.
Okay.
Yeah. Now this is see, Windows function will not assume what days or month or year I have to take. Windows function will just go by the point to point. So now if you have bring this to monthly, so it will now all the data points in your graph are monthly points. If you have changed it to day,
Correct.
all the data points are days point. Got the point? So this is the things that the Windows
Correct.
function will just, it will not look at what time period you have aggregated and what you are displaying, what time period you are displaying. It will only uh, it will just take those point, as many point the moving average you have defined here in a reverse direction, and just it will average. So you are absolutely right. What you have understood is absolutely right. San-
Okay.
Sanket,
Okay.
how about you, Sanket? Did you get this logic?
Yes, yes.
Okay. Amol, is it clear? Everybody? Okay.
Yes, fine.
Okay. And Manikant, we have never talked. Manikant.
Yeah, yes, sir.
Okay, perfect. Tarun, Gaurav. Okay. All right. So I am going to write a lot of assignment on this topic, which I have covered today and yesterday. So between these 2 days, whatever we have done, I'm going to write assignment after this class, and I will drop you an email. You will have those assignment in your email using this LODs, calculations, moving average, etc. Quick table also we have covered today. All those things you have to perform some tasks. Maybe I will give you 5 to 10 assignment. I won't give you very big assignment. I'll give you a small assignment, but those assignment will test your knowledge, like how well you have understood these things. Okay, and here I have like few of the use cases of the parameter. I'm not going to touch upon this. I'm going to first talk about the sets. I'm going to talk about the reference line. Okay, these are the really important things. And have I covered context filter with you guys? This filter?
No, no.
Okay,
No.
okay,
Uh,
perfect.
No, Ritesh.
Okay, got this. So we'll talk about this filter in the next session, and we also talk about the use cases of the parameter. Parameter, as you see, as you have already seen, to make things dynamic, everywhere we are using parameter, right? Some of the more use cases of the parameter we'll be seeing. Already I have seen you like 4 or 5 use cases of parameter, like to make moving average dynamic, to make our calculation dynamic, to make our top 10 dynamic. So wherever you want to make things dynamic, wherever you want to supply data from the user side, you can use the parameter. Yeah. All right, so I'm just going to stop it here because it's we are close to our timeline. I don't want to touch upon any new topic. I have just finished completed the calculations today, and next session we'll be covering this parameter, few cases of parameter and filters, and so on. So gradually we'll progress. So yeah, so I have like 7 minutes, so we can discuss if anyone has any concerns, any questions. uh, you know we can just discuss upon those points. Okay, perfect. So things are good. So I hope everybody is okay with this, and I'm going to share this. Let me stop this recording now.